trained and develops curriculum for CarQuest Technical Institute, as well as working with students at the Highlands College Automotive Program in Butte, Montana. Lonnie is an ASC Master Technician with A9 Light Duty Diesel and L1 and L3 Advanced Level Specialist certification. Lonnie's 30+ years experience in the automotive repair and diesel markets benefits all levels of technicians in improving their skill sets. As a former automotive repair shop owner and a diesel technician, Lonnie brings hands-on experience to the class that is relevant for technicians in the Bay. Lonnie believes that knowledge is one of the most important tools any technician can own. Thanks for being here with us today, Lonnie.
Thank you for having me today, Pamela. Thank you, everyone. Let's go ahead, and I'm going to go ahead and share my screen here. And move you all off the side there. Everybody see my screen okay?
Yep.
All right. Today I'm going to be talking about advanced alignment diagnostics, but this is just a small section of a lot larger class. And what we're going to hit today is something that was really eye-opening to me. And it deals with the vehicle in motion when it's going down the road. And compared to what our specs or our preferred alignment preference specs are when it's setting on the alignment rack, which is nice and level. And I think as we go through this today, I think we'll be able to see a few things that really stand out as important, especially if vehicles that have possibly been in a accident or have been damaged in some way, or have come from another shop into our shop and still have tire wear angles and stuff of that nation. So, or that scenario. 3 different things I'm going to talk about today. I'm going to show you what happens when the vehicle is going down the road and the suspension geometry changes a little bit, what that does to our toe and possible tire wearing angles. I'm going to talk about what happens when the steering changes, the geometry in the steering, toe out and turns. And I'm going to bring up a really cool subject called scrub radius. And we're going to go through a few things that change when our customers insist on putting different rims and tires on their vehicles, which a lot of them do. And I'm just going to show you some things to be aware of when we get to that point in the class. So what I'd like to do, if everybody's still with me here, I'd like to go ahead and start by describing what I've kind of termed as a dynamic versus static alignment. A static alignment is the toe or camber or caster. It's measured at rest, and we get our specs and from our machine, or we used to have to look them up as in the book and try to find our preferred spec. But that's just a point of reference, because your alignment rack is level. The vehicle does not have any forces acting upon the tires. Really what an engineer does at that point is tries to predict or determine what that car's suspension and what its tires do to scrub radius and different effects of the alignment is going to do when it's rolling down the road. So that's just a static alignment. And so, you guys know it's not a best practices class, but we got to make sure we keep our alignment racks level and everything clean and turning properly, so you get a good static alignment, because really the best that you do on that point of it is really going to be reflected more, and even even more important as the vehicle's going down the road in motion, which is what I call the dynamic alignment. And during the dynamic stages of alignment, as we know, we have some cars that typically are towed in on the alignment rack. Well, some cars are towed out on the alignment rack. Why is that? Well, the engineers take into consideration the road forces that are going to be acting on that car, and the most common position that car is going to be driven in is straight ahead at steady cruise. So when I'm determining how much toe in or toe out to give a car, I'm really predicting that scenario. I'm not predicting when it's braking. I'm not predicting when it's cornering. I'm really just trying to figure out what's going to happen with the bushings and everything that I have, engineered in this car when the vehicle starts to roll down the road. Of course, effects that will come upon your dynamic alignment will be acceleration, braking, cornering, and those type of things as well. So as we're predicting this, something I realized not too long in my career was that the toe angle is going to wear tires. I think everybody can agree with that. The toe angle, if you get that off, you just scrub tires completely off. One of the published industry facts that I got from the tire industry manufacturers was that if the toe setting was a 1/16 of an inch off, which is quite a bit on a modern car, but let's say it was 1/16 of an inch off from where it should be on the preferred specification, that tire in let's say we go somewhere down the road, like, I don't know, a mile. If we go 1 mile down the road, that tire, that effect of that toe angle being off will be the same as just kind of dragging that car, that tire sideways about 7 feet on the asphalt. Now, 7 feet, we probably slid a car like that going in the Walmart parking lot. But, you know, more importantly, if your toe angle's off, it's always going to be having those forces on it. So let's say you went 100 miles. Let's say you drove 100 miles on that tire with that 1/16 of an inch toe in. That's like dragging that tire sideways 1/4 of a mile. And so you can imagine how much tread you're going to have left. And so we know that the dynamic toe, how it operates going down the road, has to be very close to 0. And that's the goal of the dynamic alignment, is whatever we set it on the alignment rack, let's make sure that it's near 0 toe when it's going down the road in a straight line. Another goal too is we're going to discuss today is toe out in turns. And this is when we're going around a corner, and I will wait till I get to that section to kind of dive into it. But with this dynamic alignment in mind, let's look at a typical alignment. It's in the green. Let's just start with that. We have camber that is within the green in specs at about -0.6 of a degree. Our caster is 4.1 degrees on the left side, 4.3 degrees on the right side. It's really in a good relationship to kind of adjust itself for road crown. So I'm okay with that because the right side's a little bit more positive than the left. And my individual toe nails my total toe really good in the straight ahead position. Now, the rear of this car, if it's not adjustable, it's kind of the way it is right now. If it was an adjustable car where you could adjust the camber and the toe, I would spend a little more time on this. And I think you would too, making sure that I got it a little bit closer than what it is. But overall, I got a 1/10 of a degree of thrust angle on the bottom here. This is a green alignment. And that's kind of what a lot of guys will argue when you come back and you still have a problem with the vehicle. It doesn't drive good. Something goes wrong with it. You know, it's wearing tires, whatever it is. You know, this is the printout you give to your customer. They're going to refer back to this and say, hey, man, it was all in the green. So this is the static alignment position. Okay, we're level. Tires are pointed straight ahead. No issues. Now, the first thing I told you I was going to tell you is what happens when we have a change in suspension geometry. So what I want to show you here is a tool. You don't have to have the tool, but you know, bushings and anything to do with these control arms are definitely going to make a difference in the geometry of the suspension. And control arm bushings, no matter what they are, they're very hard to detect on the dry park steer. When the guys are on there shaking the wheel back and forth, we're getting a good look at the steering linkage. A lot of times we don't see the ball joints, but then we don't see the control arm bushings. All these things that hold the tire in the right relationship with the body, that's going to affect steering and, more importantly, in this case, suspension geometry. One tip I have noticed that during the dry park steer, if you go ahead and you press the brake pedal, have the guy that's shaking the wheel press the brake pedal, a lot of times it will load that control arm and you're more likely to see a little bit of movement in it. That's not the proper way to do it. You may miss some of them, but that is a tip. One of the problems with prying on bushings, we can pry on these bushings with pry bars or whatever in multiple directions to see if they're loose. One of the problems is if you're not on the alignment rack where the tire's in the natural position where it would be as if it was riding down the road, that bushing may tighten up. If you're in a wheel-free condition, you may miss a bad bushing. So there are special tools available. And so I just wanted to, you know, back to dynamic. I'm not trying to sell a tool here, but a dynamic alignment. This guy's arm is on this tire, which will be, the car will be loaded down on this tire even more. The brakes are set so the tire can't roll. He's going to use this tool to apply forward and backwards force on this tire. Now, this is a front wheel drive car. So as the tire spins around, the tire acts upon the road and causes the suspension to be pulled this way. In braking, it would be the exact opposite. The road would act upon the tire, causing it to pull this way. By lowering that tire on that tool, he's going to use his arm to rock it back and forth, and we're going to see if there's any type of suspension movement here. So here he goes. This technician is putting the vehicle at ride height. And we notice when he's doing that, this particular vertical mounted rear control arm bushing is moving. What's that going to do to the alignment angles? You know, what alignment angles are going to be affected if the control arm is shifting from acceleration to braking, or more importantly, is the road force or the tires acting upon the road, being able to move that control arm. So there's forces there at work that's going to change what the engineer made the dynamic alignment or the static alignment to try to predict the dynamic alignment. So making sure you get a great inspection, and also checking out some of these tools that are available to make sure that, you know, there's some of these cars like that one there, that bushing doesn't look that bad. However, that's enough movement to where premature tire wear could be a concern. And boy, if you're selling tires, that can be one of your major concerns there. Okay, the next thing I want to show you is this changes in the steering geometry. Brenda, I don't know, do we stop and ask questions, or is Jerry watching chat or anything? Do we have any questions at this point or comments?
I'm looking in the chat right now. I don't see. It's up to you,
I have
Lonnie.
one comment.
I would like to hear it.
Go ahead, Leon. Leon, you're frozen in time.
Can you hear me, Lonnie?
I can hear you now, Leon. I
Well,
couldn't
if you
before.
just-
Yep.
If you just turn it 90 degrees. Okay, 90 degrees, so that you roll the bottom of the tire in and out.
Okay, so turn this tool 90 degrees, and now there's another test, right, Leon? And what's that check?
Checks my lower ball joint.
Absolutely. Yeah. So what Leon was just, you know, and I was going past it, so I'm glad he said something. This tool actually works in this way, and also in and out too, to check, you know, wheel bearings too. I've caught with this tool as well. So
Yes.
very happy with this tool. Wish I would have thought of it, because it cost $120. So when I know it wasn't supposed to talk about that, but
Yeah, I know.
okay, well, let's go on. There are some other things here I want to just make sure that we understand when it comes to steering geometry. Now, this happens a lot, because when I was a young tech, I didn't really understand. Nobody told me about Ackerman. They told me how to turn the alignment machine on. They said, get it in the green, make sure your toe is good. They told me that, you know, toe out will wear the inside of the tires. They told me all that, but nobody ever told me about turning the vehicle in to see if the toe in relationship between the inside and outside tire stayed correct. So I didn't know about that. So, you know, as I started to learn, and especially after I had my own shop and I was selling tires, I became very interested in this type of stuff. There's a lawyer that patented this deal, this concept. His name was Ackerman, so he got his name stamped on there. It's called the Ackerman principle, or more commonly, what we call it out in the industry is toe out on turns, or TOOT. This is based on the idea that when your car is turning, you are turning around a common center point. If we're not turning around a common center point, we're going to scrub tires. And so how this is drawn, and it's not really perfect on the slide, but I'll explain it, is if we take a line perpendicular to the rear axle and it extends out for eternity, basically on both sides, and we draw a line perpendicular from the inside front tire and a line perpendicular from the outside front tire, those will travel all the way out to wherever they go, and they will, all three of those will intersect at the same spot during a cornering event. That makes sure that the tires don't scrub. Well, the reason why we call it toe out is when you're turning, If your toe was 0 straight ahead position, it's really got to toe out when you turn because the outside tire is traveling around a larger circle than the inside tire. And that being said, the tighter that you turn, the more drastic of a difference between the inside and outside tire has to be. If they both stay pointed 0 toe, the outside tire is going to be traveling around a larger circle and it's going to be scrubbing the tire off. So let's look at a steering arm. This is how they actually engineer, or how we actually get a toe out when we're trying to turn. So as we're turning, the steering arm is designed so that this will say this is the left front steering knuckle, and this is our steering arm. So if I turn my tie rod ends 4 inches inside, this tire would be the inside wheel because it would be turned this way. It's going to, because of the design and the angle of that steering arm, it's going to produce about 33 degrees of turn. Whereas if I turned it 4 inches the other way and it was the outside tire, it's only going to produce about 25 degrees. Now we measure toe out at turn at 20 degrees, but it's not linear, meaning the further that we turn it, the further the degrees get off as far as more toe out we have. And so as you can see, that's kind of a big deal. Well, I'm looking at the steering arm here. Who cares, right? It's part of the steering knuckle, but what can actually happen to that steering arm? What could happen is somebody could do a curb strike, slide the car sideways in Butte, Montana on an icy road into a curb. It's going to more than likely bend the tie rod end or your steering knuckle, okay? And your steering arm's going to be, tweaked out of position. The other thing with our newer modern cars too, we have to look at is the metallurgy that this stuff is made out of is not what it used to be. And so I got a nice lead shot ball peen hammer right there. And if you've been in the alignment industry as long as Leon and I, that hammer strikes that point on the steering arm to knock that tie rod end loose in shops all the way across America every day. Unfortunately, with the lighter design in the steering knuckles and stuff, you can actually bend them, okay? So let's just talk, we know how we can bend it. I got a great animation here just to show you the relationship of toe as it's going down the road in a straight ahead line. This was designed to travel so that our front tires will be 0 degrees. And as we turn, we're at 20 degrees now. You notice the outside is about 18 degrees. So there's about a 2-degree difference. That's really generic in difference, and it makes a big difference on how long the vehicle is and stuff. But here we have our curb strike. So let me go back just a little bit here. I'm going to go back to this point in time here on the alignment. We're coming around the corner. Everything was good. Okay. I want to make sure I highlight this curb strike that's coming up. The red portion of that steering arm got bent because that tire hit the curb. Now it goes into alignment shop. Okay, so the alignment tech sees that, hey, our toe's out. Okay, it's out quite a bit. So naturally, without being aware of toe out and turn or anything else, he sets the alignment. Now going straight down the road, we're still at 0 degrees. So we really have no problems. Notice the relationship now, and notice the black marks coming off that tire as the toe out and turns is no longer there in the right relationship. So it is a big deal. Some of the things that as far as tips go here is if a vehicle comes in and it needs a large adjustment, I want to know why the toe needs to be adjusted that far. I also want to know before I put an aftermarket shim in, before I do anything else, what in the world happened to this vehicle, and has something else changed? Okay, so let me look at chat here a little bit. No more set toe and let it go. I get that. Get it in the green, Adam Robertson says. How's that work with custom rims and suspension? It really doesn't. And so one of the things Jerry Barson was kind of leaning towards there too is If you have like a van conversion that's been lengthened, or a limousine that's been added a chunk of frame in, this all goes out the window. Those cars are going to wear tires. You need to know that, especially if you're in the fleet alignments. Anybody else have something they want to chime in? Let's look at it here as we go through. I'll just take a short screen here. This is the vehicle turned at 20 degrees. Turn 20 degrees to the left. We see that it's about 2 degrees more than the right side. That's our toe out and turns. Notice it's not as much at 10 degrees as it was at 20 degrees. Okay, that means it's not linear. That means it's going to grow as it gets wider and wider. More and more, closer I get to 20 degrees. Now I got a couple examples here. I have a pretty good one on top. We're at 20 degrees. We have over 1.5 degrees toe out and turns. Depending on how long that car is, that may be perfect. Okay. Now look at the bottom. I have a 20 degree and it's a 15.8. So I have about 5 degrees difference. That may or may not be too much. How do I know? Well, I'm going to do the toe out and turn measurement on both sides. So when I turn it to the right, if it's still not 4 degrees, something's bent. Okay, if it goes to 1 degrees, then something's bent. Okay, so there's specs for this, but both sides, if it shows a 2 degrees difference in toe out and turns, when you turn the wheel one direction, you want to turn and you want to do it to the other direction. They better be really close to being equal. Just because not everybody, you know, I mean, I know we have Hunter alignment machines, and I'm not promoting any type of alignment machine, but these screens are from a John Bean. What if you're a guy that just has a turntable? Well, make sure you have a degreed turntable. We used to do these manually without the aid of the machine. We would turn it to the inside tire was at 20. We would walk around the vehicle. We'd look at the outside tire, and we would make sure that they were the same, or they had the toe out and turn on both sides were the same. All right, guys. Well, this is a big topic here. This is going to take a little bit more of time than the other two. So we've seen changes in suspension. We've seen changes in steering geometry. And now I really want to talk about changes in scrub radius, which for the most part may or may not be a common term with a lot of your alignment technicians, especially because we've had to train them on the fly so that they've learned to turn the machine on and do alignments. We may have one guy for a big shop that has a really good alignment guy that understands some of the diagnostic angles. Scrub radius is one of those things you got to keep in the back of your mind when you're doing any type of alterations on a vehicle, or a vehicle comes into your shop that has been altered. And when I say alterations, guys, we got lowering kits, we got lift kits, we got wider rims, we got taller tires, we got lower profile tires, we have all of the above, a large gamut that, you know, the American public loves to do that stuff. They love to make it their own. Fast and Furious caused a bunch more cars to be modified. They don't always drive good, okay? And I get that. Some of that lies on them. We can tell them right off the bat, you know, disclaimer on the alignment, this is an altered vehicle. I can't help you with that. However, understanding it may give us a little bit more of an insight on what not to do if we're a tire shop, what to look out for to really have a conversation with the customer. And also, if you're interested in doing that kind of stuff yourself, which I love to do off-road modifications, scrub radius has taught me to take a measurement before and after the alteration and make sure your scrub radius is almost the same. And you'll see why when I get done with this presentation. This right here, the picture that's on the screen right now, is not uncommon. We see a lot of, this is a Chevy pickup, by the way. It's got a larger rim than it came with stock. This is an 18. It's also got a wider rim than it came with stock, with a different offset than it came with stock. And a tire that's a slightly larger than stock, but not overkill. There's no lift kit on this truck. Okay, so they've done some modifications. They want the tires to stick out a little bit. Looks tougher on Saturday night when they're cruising the mall. Okay, so I'm sure a lot of you guys have seen this in your shops. So very common way to do it. Okay, so what I want to ask is this. Okay, when you see these, this truck right here has got a problem. It's typically wears these Wranglers out in no time. Okay, so where this tire would make it 30,000 miles on this truck, yeah, this guy is getting 15 to 20,000 miles on this truck, and there's toe wear and cupping that happened, and he's put shocks on it, and he's done other things. So this was a student of mine. And so he brings it in. And so what effect does the height of the tire and the rim offset have on the dynamic alignment? Well, we know that especially on wheel bearings, I mean, if you get a very large rim and it's a plus size rim with a lower profile tire, it puts a lot more pressure on that wheel bearing. Well, that's not what I'm talking about. I'm really talking about how does it affect the toe? How does it affect the dynamic toe? Because man, that's what's going to wear tires, right? So before I get into scrub radius, what I really want to do is I want to show you how we get scrub radius first. And there's a disclaimer on all this stuff too, because man, I've went down scenarios with guys where, man, everything is bent and everything is wore out and it's all wrong. And come to find out we didn't do the rollback compensation, maybe good enough, or something has changed, or the camber angle wasn't set as close as it could be. There's a problem with our best practices that are leading us to a false conclusion. So with that being said, we'll come back and remind you of that later, but how do we measure scrub radius? Well, what's the purpose of scrub radius? Is scrub radius just determines where the tire is going to turn around, and it's measured using the SAI angle, or ball joint inclination, kingpin inclination, some other terms that we use in the industry. It's the same line that if we were looking on the side of the car to determine what caster was, it's drawn through the upper pivot point center, through the lower pivot point center, except for SAI, we're looking at it from the front of the vehicle. So we see our SAI line and we see our true vertical line, okay? And so the degree of SAI is the difference between true vertical and the center line between our steering axes. Short long arms tend to be a little less, and McPherson struts had a pretty good angle for that strut to come down in there from the upper pivot point. So they would have, maybe more SAI. So SAI is a diagnostic angle I look at it on vehicles almost every time because I want to make sure it's pretty close to being even side to side. Okay, so it can cause some weird pulls and some other things that may not be reflected in the caster angle. So I just want to make sure that it's pretty close. Control arms aren't bent and things of that nature. So we use this angle right here, the SAI, and we also use the center of the tire line directly in the center to measure what we call scrub radius. And I'm going to go ahead and play this little animation here. And what this animation shows us is positive scrub radius is when the SAI angle lands on the inside of the tire, true vertical center line, and negative is when it's on the outside of the tire. So I'm going to break that down just a little bit here as we look. This is positive scrub radius. What I mean, SAI angle is intersecting the road surface on the inside of the tire center line. Well, what does that mean to us? Well, here's the thing. That toe angle we were talking about sometimes being positive, sometimes being negative. Well, it has an effect on what happens dynamically. If we have a positive scrub radius, this section of the tire here, there's more tire outside of the SAI line than there is inside the SAI line. Meaning, if I was going to call this a handle, I have a shorter handle on this side, I have a longer handle on this side, and the road force or tire force acting upon that handle is what's going to change my toe as I go down the road. Now, this is a front wheel drive vehicle, which means that the longer handle is going to be pulled because the tire is acting upon the road surface. So on this particular vehicle, my static alignment spec, while it's on the alignment rack, may be towed out. And the reason why it's towed out is when I'm going down the road driving at steady cruise, this longer handle on this side is getting pulled more than the shorter handle on this side, causing the tire, if we're looking directly at it, to toe in during the dynamic alignment. Okay, well, that's pretty cool. If it was rear wheel drive, it would do just the opposite. And that makes a little more sense because all of our toe specs used to be towed in from the factory when we had rear wheel drive cars, because the tire was the handle was getting pushed on by the road surface because it wasn't a drive tire. In that case, the tire would tend to toe out with positive scrub radius. And so the predictive of the toe angle is really coming from the scrub radius. And not all of them are positive. We have negative scrub radius where the SAI intersects the road surface outside the tire. Okay. And very few older cars have 0 scrub radius. However, with the advancements in electrical power steering, we're starting to see a lot more cars with scrub radius closer to 0 than we did before. The reason why is you got to think about this handle. Okay, I'm talking about steady cruise for the alignment, but what about during braking? Well, it changes the tire orientation quite a bit. What about during acceleration, especially when I'm only accelerating with one tire? What are you talking about accelerating with one tire? Talk about torque steer. And front wheel drive cars have a lot more horsepower than they used to be. If one tire is receiving most of the torque through that axle, its handle is going to be pulling. That's what causes torque steer. So, you know, industry, we're trying to push it towards more scrub or less scrub, 0 scrub radius than we used to. That Honda Type R that's got the 300 and some horsepower, it's got almost 0 scrub radius. They say that's why it doesn't have much torque steer. Okay. So that's how scrub radius is determined. Now let's go back what I'm talking about today. Changes to the intended scrub radius. Well, how would you ever change it? You can't adjust it in the conventional way where you turn an eccentric or turn something else. Okay. But you can mess it up. Let's just put it that way. If this is the stock tire on this side, then I'm circling with my arrow. The SAI line intersects the tire surface on the inside of the tire center line. So it's got positive scrub radius. It's rear wheel drive. So we're looking at it. So a positive scrub radius. We have a long handle on this side that's getting pushed upon as the vehicle is being driven down the road. Okay. So as I'm pushing on it, that's going to tend to tow the tire out. So my alignment spec will be towed in at that point. Now, I do what my friend did with the Chevy truck. I put a wider tire on, but I leave the rim offset about the same. I kind of split the two sides, but a much wider rim. So now the tire sticks further out on the side of the vehicle. What happened to my scrub radius? Well, the tire center line's got to move with your rim alteration. There's no way around that. Now my SAI line intersects even further. So now my handle's way more than this handle. Okay, so now if I set it to factory specs to compensate for the road pushing on that handle more than it's pushing on this handle, then I'm not going to have enough toe in because it's going to tow it out further than it was designed. Now, the opposite is true with a different negative face rim here. When I get a negative scrub radius and my stock specifications are for a positive scrub radius, it's really going to wear tires. There's nothing really we can do about that at that point. So avoiding these situations, or at least trying to return it back to the same, is what we're looking at. So you guys that sell rims, you know, offset is king on this stuff. But offset's also influenced on what offset I have. Is if I just have a stock tire, okay, a stock rim, and I just put a bigger tire on it. This is becoming more and more popular because I have a Tacoma. The stock rims are nice. There's nothing wrong with them. They got the factory TPMS sensors in them. I'm okay with that. But I would like to plus size my tire a little bit. If I plus size my tire, this is my SAI line. This is my tire center line. Let me back that up. It had a little positive scrub radius before. As the tire size grows, takes my scrub radius away. Okay, so if I just put a much larger tire on a stock rim, I ruin my scrub radius just as bad, not quite just as bad, but as bad as if I put the wrong set offset rim on it too. So it's very important to keep this in consideration. If I put a larger tire on, what else do I got to do? I got to change the offset of my rim a little bit to move the center line over so that my scrub radius is near what it was when it came from the factory. I get a little pushback on this because the guys, some guys that I've talked to about this say, well, you know, Lonnie, if I'm only going from a 265/70 to a 265/75, that's not going to change that very much. And he's absolutely right. It's not going to. But if I go from a 265/70/16 to a 315/75/16, it's going to change it quite a bit. And I'm going to lose my scrub radius. And now my factory alignment spec is actually going to cause tire wear instead of prevent it. Now, the same is true with a lower profile tire on the stock rim. As you notice, it gave more positive scrub radius, which we kind of described that scenario a little bit earlier. So I want to do an example here. This is kind of how I deal with it at school. And you don't always have a like vehicle, and I get there's no answers to some things, but you just got to recognize what's causing the problem. This is what I've been in a habit of doing, is storing stock vehicles. This is a 2011 Silverado. No lift kit, stock rims and tires on it. I do an alignment, pretty good alignment. The SAI angle is fairly close. The included angle is really good, so that my camber and my SAI come out really even on both sides. This particular alignment machine takes the SAI angle, it measures it during the caster sweep. They all do. So here's another tip. I found that if you don't start that engine before you do your caster sweep, when you put on your brakes to lock that tire to prevent any type of roll during your alignment, during your caster sweep, a lot of times it won't be close enough for you to actually see. So that I've started now, I get ready, I do my rollback compensation. It tells me to install the brake pedal before I depressor, before I do my caster sweep. I get in, I start the vehicle. Now I have brake assist, and I push that brake pedal down, and then I install my brake pedal depressor, and I have very few warnings that you had a roll during the caster sweep after that. Okay, it's just a way to get a little more even and more accurate. So this truck, about 1.8 inches, and scrub radius is measured in inches. So excuse me, 1.8 inches of scrub radius, that's going to be normal. Now we're going to go back to this vehicle, which has a new tire size of 32.3, which is only a half an inch taller than the stock one, not a big increase. It's got a 3-inch wider rim on it. It has a little bit of offset difference between the two, about, a little over half an inch if you're an inch guy of offset difference, but you can tell that's not the stock rim. Okay, so in this case, what's going to happen? Well, what's going to happen is, as you can see, the center of the tire came out on the vehicle. Now I'm going to flash back to this other one. You can see the dish right there on the tire, and you can see how far this tire sticks out past the bumper. So if this was stock, this was our positive scrub radius. This is after the modification, because our tire size really didn't get too much bigger there. Okay, so we'd expect our scrub radius to be much larger on our alignment machine than the one I just showed you that was 1.8. So that would be one way to reduce it, but we did not do that on this car or this truck. And here's my scrub radius measurements after the wheels and tires were installed. So the 2011 I showed you first, that was a stock, same suspension system. This one is a 2009 with the wheel modification. Now it's got 4.3 inches, 4.2 inches, over twice the amount of scrub radius than what it came with from the factory. So if the toe in spec was, towed in, a tenth of a degree on each side from the factory, is that going to be adequate here? Do you double it? What do you do at that point? Okay, so it puts you in this jackpot kind of where you have a condition that is creating a real issue right there. Before I go to this slide, I'd just like to ask one more time if you guys can chime in if we have any questions before I kind of talk through. I got a little bit I want to kind of tidy up on the end, but I would like to hear some feedback from anybody.
Well, I would like to say that Jerry has put in the chat that these are outstanding examples, Lonnie. Thank you.
Yeah, I know he did. I see that. Yeah.
Mhm.
One of the things that you have to remember too, there's so many different facets of this. When we go to the whole class that we teach with this, um, changing the SAI angle from factory with different lift kit scenarios and stuff also fits a whole different realm into this. And so, as far as the tips go, the alignment best practices are critical. So if you see something, this is what I do, and I get my students to do it because I feel that they want something to be bad. They get so excited about the diagnostic angles when I tell them, and different technicians, they get so excited about this part. And the other part is with diagnostic angles like SAI and included angle. If you get a chance to see this whole class, we can see what's bent on the car. If we have a camber angle that just won't come back into spec or is way off, and we're using, aftermarket shims and stuff, we can see what's bent with those type of angles. So there's so much fun with this. I mean, I like aligning cars, as you can kind of tell, and guys that aren't aligning, guys that don't like it, really shouldn't align cars because they're not a money maker, they're a challenge. But what it comes down to is they'll come up to me with oh man, included angles high, SAI low, and then whatever, but it's a scenario that's really strange. And most of the time I find that something happened during the rollback compensation, which is good to catch because may not have caught it before by just performing the stock alignment. Let me say that again, because that's important. I set the camber, caster, toe, front and rear on a vehicle. I'm getting ready to set it out. I go to my diagnostic angles. If my rollback wasn't accurate, that alignment's not accurate. And it usually shows up in the diagnostic angles, like SAI and included angle. And the first thing I do is I start over, do another rollback, do another caster sweep, make sure that those angles are consistent. So is my alignment the same as it was before or pretty close? And if it is, then I have a problem. If it's not, then I need to go ahead and make my adjustments again, make sure they're as accurate as possible, and go ahead and take care of that. So some of the things we got to make sure we look at is make sure the tires are the same all the way around. I see that every once in a while, one of the tires will be the wrong size. I see guys that get way into the alignment and they're almost done and they have a low tire. I'm like, dude, that just changed your ride height. That changed everything. You wasted a whole bunch of time. So we got to make sure it's got the same tires on it. Make sure the tire pressure is the same in all the tires and where it should be. And before you use anything to determine what SAI is or anything else, especially when we're trying to determine if scrub radius is within spec, make sure your camber adjustment and your caster and toe are as close to spec as you possibly can. Okay. And so that when we're using those diagnostic charts, it's always assuming you've tried to do the best alignment possible before you got to this point. My other tip there is when performing suspension, tire, and rim modifications, it's a good idea to try to, it's going to be hard to get guys to do this every time, but do an alignment before and then do an alignment after. The alignment before is to make sure that you have a baseline of that vehicle's stock and that there's not any underlying issues before you begin. And then your after one would make sure that your scrub radius and other angles came within reason so that the vehicle would be able to drive okay. And the other tip there would be, remember that the rim offset is the easiest way to change scrub radius. If you get one with 5 inches of scrub radius, that's way too much. You've got a wheel offset issue. And the only way to change that would be to move it back and forth. So guys, I kind of rushed through that tonight because I knew we were on lunch, but that's what I have. And I see right here, Jerry Barson sent out a nice little chat here. He says, and then came Addis. Okay, well, Addis has some advantages with tires and alignments that we're just now starting to see that vehicle pulls aren't probably as prominent as they used to be, because with your torque sensors and your steering wheel and electric power steering, taking and relieving that off of the driver, he doesn't really feel the pull as much as he used to be, unless that steering wheel is not centered, unless you haven't told the system where the center of the steering is, and then on the other hand, when you're trying to brake or accelerate, if these type of angles have been modified, the force on the tires, how short your stopping distance is, a lot of things can change. And guys, I'm going to tell you right now, with emergency stop and fail-safe stop features with, cruise controls and everything that we're seeing on just about all makes and models, you better make sure that that vehicle stops the way it was intended to, the way the programming inside that ADAS system was designed to handle that vehicle. Okay, well,
Hey, Lonnie, also another question. And again, this just comes from I don't know, an enthusiast, not a guy that's doing alignments every day. But I understand, like when we're talking toe out and toe in and all these things, measuring them in degrees, because degrees stay consistent regardless of the size of the tire. But when people, then people make the pivot, right? And they talk about, you mentioned a few times, like a 1/16 of an inch of toe out, right? And so that is all relative, right? To the height of the tire or the size of the tire.
Yeah, and it's also relative to your specs, because you got to remember the older cars, especially in the 60s and 70s, all we had was, we had camber in degrees, but our toes were usually in inches. And that's the way the spec was. Degrees became a more modern term, but if you're an alignment shop in a body shop that actually does frame straightening, you actually talk in minutes. So it really just goes back to, hey, we just go check and see what the spec says. Well, if the spec's in degrees, that's where I'm at. If the spec's in inches, go ahead.
Using your common example of a truck where I'm putting on oversized tires, right? So that thing came with whatever 245, 75 R16s or whatever, right? So it's a 3/4 ton heavy, and then I put some massive tires on it. Then if I was aligning that thing to whatever, a little bit of toe out or something, then just the fact that I went to a large tire means it's going to be a lot more toe out, even if I keep things consistent, right? Like it, because in inches
I see what you're saying, because you're talking about there's a longer distance from the center to the outside of the tire. However, that angle is actually not relative to that. If it's towed in 1 degree, sure, it's going to go out there 1 degree, but that's the same angle as it would be if it's a short tire and a long tire. You just see it reflected. It's still going to wear, even though it's a smaller tire than a larger tire. If it's off, like let's just say it's towed in a 1/2 degree. If it's towed in a 1/2 degree, that's a lot of towing. Okay, so it's typically going to wear the outside of the tires. Both sides tires would wear the outside of the tires the same.
Right, got it. And so degrees is great because it's consistent regardless of the size of tire. Inches is less consistent, I guess, is where I was going with that.
Sure, because you're making a mark on the, especially if you're making a mark on the ground, or or sticking a rod between the tire, and different things, it's different. One last thing on this scrub radius thing that's interesting is when you're doing alignment, you've been messing with stuff like that. You push on the outside of the tire, you push on the inside of the tire. Which side of the tire do you push on, the front or the back, to kind of relax that, to simulate road force on that tire. And I never even thought about that until working on European cars. A lot of the Mercedes have a tow bar that you're supposed to put in that has spring pressure that simulates the scrub radius force on the tire when it's driving, and then you set the toe angle to 0. So if you're not aware of using that bar and you think, well, I don't need it, and you just set your toe at 0 and you don't have that force acting upon the tire, you've set the alignment angle wrong too. So there's a lot of tips and tricks I could spend a lot of time showing, to keep that in mind, especially on larger trucks where they do have big tires. And I know the scrub radius is acting on them. I'll push on those tires, both tires the same, and watch my toe, make sure it comes back to where I set it. If it changes completely, I'm definitely concerned about that alignment. Okay, so any type of specs today is your last takeaway. They're only reliable when the components are solid, making sure the components are not bent. Scrub radius has a large effect is affected largely by modifications, and make sure we do our best practices. Okay, I'm going to stop my screen share now.
Okay, well, I would just like to thank you, Lonnie, for a great and informative presentation
Thank you.
from all of us at ASA Northwest.
Yeah,
You're welcome.
Lonnie, this is
Yes, sir.
Jerry.
Yep.
You know, the reason that I brought up the ADAS business was because of the fact that more and more alignment shops are finding the need to invest in going that direction. And it's you know, the high-end car dealers, because I've been there, I've seen them, I've talked with technicians, and I've talked with owners, and they all say the same thing. Darn it, we got to invest all this money in targets and all this other stuff, you know, and a space. But you know, it plays a role, and the alignment business today is way different than it was in the past. You mentioned the 60s and 70s. That was a piece of cake. You know, it was set the tone and let it go. Get it in the green or get the dials set right, because that's old school like me. You know, we had dials and we had you know, move the needle, that kind of thing. But it's a whole different world, and I think you did a fantastic job answering some questions, going toward some of the topics that were brought up that deal with this, and just really good job overall. So thank you.
Oh, thanks, Sherry.
Yeah, Lonnie, that was incredible. And I think one of the takeaways for this, at least for me and from what I see out there, is how much of this is really not talked about, honestly, out in the field. I was that same alignment tech back in the day when you learned too, Lonnie. And look, alignments and shims, and you know, we're putting in eccentrics and all that. It was nothing, and no one took the time to share with us at that time how important all this was. We just didn't know. And even today, alignment techs, you know, they'll look at a topic like alignment and they'll go, well, you know, we already know that's pretty basic. I think to myself, oh, you're so wrong. You really don't have a clue what's really going on out there. And it was just awesome. What a great presentation day. I loved it.
Thanks, Adam. And you're absolutely right. I mean, guys that come to this class because it's the only class that has available seats, because all the other classes are sold out, they leave going, holy crap, I had no idea, you know. And that's usually how I fill my class, unfortunately, because they hear alignment, they're like, oh, you know, I don't know, but there's a lot to it. And when I was a young tech, I didn't know any of this. I just did what I was told, you know.
Okay, well, again, thank you so much, Lonnie. We appreciate your support and CTI's support as well.
You are welcome.
All right, thank you, and everyone have a great afternoon.
See ya.